the power developed by a turbine 10,000 kilowatt when running at 100 rpm. The head of the turbine is 30 meters. If the head of the turbine is reduced to 10 meters, determine the speed and the power developed by the turbine. So to solve this problem, we have to apply the concept of unit quantities. Okay. So using unit quantities, we can find speed and power of the turbine or discharge of the turbine for different heads. Okay. Or when turbine working under different heads. Okay. Na? So turbine అనేది for example hydraulic turbine different heads దగ్గర వర్క్ చేసినప్పుడు different heads nothing but height, okay, water level. So power, speed, discharge ఇవన్నీ కూడా మనం స్టడీ చేయొచ్చు using unit quantities. Here head is reduced to what is the initial head here? Initial head is 30 meters and the reduced head is 10 meters. We have to find speed and power. Okay now. So new speed and new power. So anyhow, first note down the given data. Power developed by the turbine, initial power. So P1 is equal to given 10,000 kilowatt initial power. And initial speed also given 100 rpm. 100 rpm. And the initial head H1 is equal to 30 meters. And what about final head? Reduced head is 10 meters. New head is 10 meters. 30 meters నుంచి 10 meters ki head reduce అయింది height water level. Now we need to find power developed by the turbine and the speed of the turbine. Okay na? When turbine working under a head of 10 meters. So apply unit quantities. Unit quantities concept. Simple concept. Unit quantities. Okay. So according to unit quantities, unit speed is equal to n by root h and unit discharge is equal to q by root h and unit power is equal to p by h power 3 by 2. Okay. From these relations we can write, for example we have two different speeds and two different heads. So we can write this as n1 by root h1 is equal to n2 by root h2. Similarly q1 by root h1 is equal to q2 by root h2. Similarly p1 by h1 power 3 by 2 is equal to p2 by h2 power 3 by 2. Okay. So we need new speed and a new power. So from this formula we need n2 here. So n2 is equal to transpose root h2. Okay, now division becomes multiplication. So n1 into root h2 by root h1. Okay na? So in numerator we have root h2 by root h1. So root over h2 by h1. Okay. Okay. n2 is equal to n1 how much? What is n1? 100 rpm into root over h2. So reduce h 10. Initial head 30 meters. So 10 ones 10 threes. We will get n2 as n2 is equal to 100 into so root over 10 ones 10 root over 1 by 2 root over 1 by 3. If you calculate this you will get 57 point approximately 57.74 rpm. Okay, this is the new speed 57.74 rpm. What about new speed? Sorry, new power. This is new speed. Now we need power developed by the turbine when turbine working under 10 meters, head of 10 meters. So P2 is equal to transpose H2 power 3 by 2. Okay, now division becomes multiplication. Actually we will get P1 into H power H2 power 3 by 2 by H1 power 3 by 2. So it's like A power m by B power m. A by B whole power. P1 into H2 by H1 whole power m 3 by 2. Now P2 is equal to P1 initial power 10,000 kilowatts into H2 10 by H1 30 power 3 by 2. So now P2 is equal to 10,000 into 10 ones 10 threes 1 by 3 power 3 by 2. 1 by 3 power 3 by 2. So let us calculate this value. get, if you calculate, you will get P2 is equal to 1924.5 kilowatts. This much power developed by the turbine when turbine working under 10 meters head. Okay.